Hello, hi everybody. Good morning, good afternoon, or good evening, depending on the place where you are connecting from. Welcome to our subject talk about open source, AI, and the new attack surface. Open source now sits inside every product, every service, and every pipeline. It accelerates the innovation and gives the teams the freedom to build at a global scale. It also expands the exposure because at the end, every dependency, every transitive library, every snip created with AI, LLM, and these kind of things, and every automated build steps becomes a potential entry point for attackers. So this attack surface is growing faster than many organizations can track, verify, or even control. AI amplifies this shift. It produces code at machine speeds, influences the package choices while we are developing. It interacts with ecosystems that attackers already target. We see the AI craft malware, automated dependency abuse, poisoned models, large-scale trust attacks like a Singularity or Cloud Code. At the end, offense has become more adaptive and more automated, and the supply chain reflects that pressure. Our goal today is not only to map the threat landscape, but also to understand how defenders respond. We want to explore smarter defenses, AI-assisted triage, SBOM intelligence, supply chain visibility, everything, all the different assets and aspects across the modern software development lifecycle. We want to ensure that discussion in practical experience. So for that, we come today with a different or a very interesting set of different points of view on red team, blue team, purple team, visibility for the supply chain, everything. So thank you very much for joining us, Leon, Roman, and Luis. Roman, principal architect at Red Hat, he works across the open source communities and leads efforts to strengthen the trust, governance, and security across all these ecosystems. Thank you very much, Roman, for being here and for joining today with us.
Thanks for having me.
Same. Thank you for having me.
Leon Johnson, offensive security and AI security leader. His work reveals how attackers exploit AI development or AI-based development, how it flows, and how trust boundaries fail under automation. So thank you very much also, Leon, for your experience and your point of view today here. And Luis Rodriguez, CTO at Xygeni, that has a fantastic perspective around the software supply chain, the risk on this in this aspect, advanced analysis of dependencies. Thank you very much, Luis, for joining us today also.
It's a pleasure.
Fantastic. So let's start. Just to put us on a stage and to warm up. Just a very quick question, just for your summary or your view, your thought in 1 minute about if open source is everywhere, what does it mean for innovation, exposure, and control in this AI-driven world? I don't know your first thought or your main ideas at this respect.
I can start, probably, if you don't mind. Yes, open source is everywhere, and it's my pleasure to hear it because we are at Red Hat truly believe in this. And upstream for us means downstream. Basically, the majority of the things that we do is in open source. We at Red Hat even internally work in the open source way, right? That means, again, almost that we do happen in upstream. The beauty of open source and its culture, in my opinion, spans over the notion that all communities are different, right? Which brings diversity and that magic, if you would, that speeds up innovation. So as Red Hatters, we contribute to thousands of upstream projects, of course, and you will not be surprised, but they don't necessarily all agree with us and with our security approaches and on AI policy as well. So that's a challenge on the one hand, but that's so exciting on the other hand, try to kind of break these ices and to build these bridges.
Thank you very much, Roman. You can speak in different order. It's up to you, okay? Though there is not a specific order here. So the idea is to have a discussion among all of you, just to share the ideas, experiences, and all these point of view. Okay? So please.
I'll jump in. I think the fact that a lot of things moving to open source is great because it makes everything transparent. And that way, everybody has a look, everyone has a turn, everyone sort of evaluates what's going on. And so everyone has a say, as you said. Everyone doesn't always agree, but I think it's much better than there being a mask of security, because what happens is when you're hiding it, you're not always so willing to shine a light on the issues. And so when the things are reported, you don't always find out about it. And what I'm starting to see, I think, is there's a culture of people willing to speak up when things are getting compromised, because they're getting compromised at a scale that's unprecedented right now, and people are having to respond to it. And they're such large compromises that if they were to go unspoken about, then I think it would hurt the community as a whole, everybody. And so we're starting to realize how much more connected we are. You see a lot of memes now with all the different components of the internet and stack, and so I think it's great. But it also means that the attacks are accelerating just as fast because we all have visibility to it. And now the bar's been lowered, because AI so any random person can just say, "Oh, look at this code, find me vulnerabilities," and throw some mud at the wall, see if it sticks.
Thank you very much, Leon.
On my side, yeah, I think that the open source community is vibrant, really vibrant, and they try to do the best they can. But obviously, I am the frightening man. I need to worry, to put some ideas on what could be better, done better for reducing the risk. It's not an easy task, because obviously you have the open source, the source code available, which is not common in closed source. But who cares about analyzing what's going on with the source code of third-party projects? Nobody cares. You need to have automation for escalating the hard work of analyzing the security of third-party open source components. And you need automation, you need AI, you need a lot of tools, because 80% or even more than of the software is made by these open source components. So I think there is an ongoing process to improve on the risk management of this part of the software, and we will see a lot of changes in the near term.
Thank you very much, Luis. Well, I think it's a good starting point and some ideas on the table. Thank you very much. Let's start with, as usual, some introduction and some of the topics that I introduced before. At the end, we mentioned that the open source is everywhere, is more present, and is growing, as you have mentioned. We have dependencies, we have models, we have data sets, we have code generated by the artificial intelligence. So at the end, what we are doing is we are putting more models, more dependencies, more things and this is growing the surface for attackers. Okay, so at the end, we cannot stop this usage. So the challenge is finding a balance between the openness and the usage of these components, and how we keep the control to ensure that everything and the ecosystems are safe. Okay, so with this, I'm going to launch some questions based more or less in your experience, but feel free to contribute to any of them. Okay, it's not for one of you. I don't know, Roman, for example, you have a lot of experience. So you mentioned that you work in the open source way, even internally. So are you dealing with this, and how do you think that the organizations can balance this openness, transparency, control, and everything?
Yeah, that's a very good question actually, and there are certainly a lot of risks that come in from open source. And now that AI amplifies things, of course, I agree with you guys. That's the attack surface is expanding, and the speed we need to react to this attack is also should be faster. I think. From our perspective, I will break it down to two kind of major points. One of them is AI contributions. As we work in open source, of course, there are enormous amounts of AI-assisted code contributions, and there are again different approaches. Some communities agree, some communities disagree that we should even allow those AI contributions, but our perspective on it is we just can't avoid AI, right? We don't ban AI because it would lead to shadow AI and other bad consequences. We rather wanted to guide developers, including those in open source, how to cook it right. And one approach towards it is to actually educate them how to write secure code using AI assistance. That's why I think it's very, very important that we work among other industry leaders within the communities like Open Source Security Foundation or OpenSSF. Recently, we produced the free class for all the developers, how to use AI assistance to produce the secure code. So that secure code is ingested in the right way into the open source, and of course it's also applicable to companies as well, right? And this guide is very concise, and it includes some of the tips. It's developer centric. For example, it provides some of the prompts example, like not, hey, write me the crypto function or write me the authorization form, but how to improve this prompt so that AI assistant can write it in secure manner. So that's things I see already improving the quality and security of the code that is written using AI assistance. The second aspect is trust. As you mentioned, or rather zero trust. Actually, this is not new concept in security, right? Zero trust, but with AI, it's just getting to larger scale, and trust starts with provenance, right? So there's if you look into how we or developers right now write the code, or how companies build the AI stack, right? They consume the models right away from the hubs like Hugging Face, for example. And as you mentioned, nobody really cares what's in it, right? What artifacts or malicious binaries can be included into it, and what data was used to train these models. And also when end users interact with the systems, how the system is constructed and what are the security controls for this system, and what constitutes of these AI systems like GPT, for example. So I think our future is to standardize these things, but also provide the tools for both for development teams and security teams to again to cook it right, to build the secure AI system. So that's kind of the high level how I see things.
I'm going to ask later about these tools to see if they are the same more or less, or some similarities or something like that. It's interesting. Thank you very much, Roman. I don't know if anyone can want to say something else. Probably, Leon, you have an approach more from the offensive perspective. I don't know, for example, with all these new potential entry points, how does the threat surface shift from the attackers, or what are the weaknesses that are more usual in your work, or you find more usual in your work?
So from my perspective, we haven't had a shortage of attack surface in general, and so um, I think the industry as a whole was having a hard time keeping up with the attack surface as it existed. And now what's happening is both the attackers and the defenders couldn't survey the entire landscape, but now the attackers have tools to evaluate quicker the landscape. So outside of even secure code, there's just things that already exist that we can find now that we didn't have the ability to find before. So there's a lot of things that were as you know, as you like things pop up, take you back old school, like Mimikatz. It was around forever, but we didn't know about it until someone researcher did the research and found the vulnerability, and we're like, oh, this is very bad. And now AI is accelerating that on a larger scale. So before we even start attacking the AI, there's just the AI is helping us find all the bugs that were there to begin with. And then you have the problem of the complexity of all these systems, because even if the code is secure, it all has to connect with each other. And then that's an attack vector, an attack surface that exists. And so that's a problem. And then on top of that, you have AI that allows you to just sort of do whatever you want. And there's no like real constrained, defined limits on what it is. It's just language. And as we know, historically speaking, blacklisting things is not a good protection system. So there's no way you can blacklist all the things. So all you can do is whitelist the things, but you can't really whitelist language. So it makes it even more difficult. So from an attacker's perspective, it's a field day. It's like back in the 80s where everything's, yay, we're running around having a great old time. I honestly think it's going to take a bit of time before, as a whole, we figure out what's the right way to protect all these systems. And then that gets disseminated broadly where everybody, including developers who work in small companies, understand, okay, we should probably use this protection, guardrail, whatever, what have you. And right now, I just think we're all still trying to figure it out, because the developers are still trying to figure out what's the optimal way to use this, like the MCP is using so many tokens. And so there's a lot of things that are business drivers that are taking precedent over security. And I think it's going to be, and that's why I think we're seeing such the volume of things happening at the scale they're happening. I think it's going to take some sort of major event before we have like the way TSA has like take your shoes off at the plane now. We won't be able to use AI for certain reasons. I think that's, I don't know if that's going to happen or not. So that's just my perspective.
Thank you very much. Please.
I can give just one thing about dependencies management. With AI coding agents, we are seeing a dependency churn. Those assistants are trained to make things easier, and they don't think much about adding a new dependency. If they find some open source component that fits the bill, instead of working with the basic SDK or the basic libraries, they get the dependency inserted in the package manager, in the dependencies manifest. So you get a lot of artificial dependencies, and with dependencies come the increased attack surface. You need to worry about more vulnerabilities, more dependencies, transitive, and you get a lot of inferno of dependencies, as I call. And the problem is that, well, by coding is even worse. If you don't know what you are doing and you tell, do this in this way, and you let the agent be free when deciding which components to add, they add everything they can. Because the problem is that the irony is that AI could theoretically help reduce dependencies if prompted correctly. If I tell, okay, try to make this behavior, instead of using this library, try to use because you are only using this particular function, and the library is huge. You need to re-implement perhaps the same small fragment of code you are trying to use by importing the library. So I think the default behavior of coding agents is to make things easier and add any libraries needed. and secure by default is not the posture embedded in such tools.
I think you're actually going to see a boom in businesses that are focused around that solution, specifically trying to like mitigate the packages. I've already seen them popping up left and right. Everybody's trying to like, we can protect you from these types of attacks.
Yeah, absolutely. So go ahead.
No, go ahead, Roman, please. Go ahead.
Yeah, I was actually referencing to your thoughts, Leon, about this is not necessarily the brand new method of attacks, and as we already mentioned, this is all like supply chain issues that that's with us for decades now, right? All of these dependencies and etc. That's just getting the more the another flavor, I would say, as for example, those LLMs hallucinate with the fake packages, right? Like this story with cloud code, right? And the developers just include them right away. So this is not necessarily AI, powered attack, but with a sexy, new namings, it's getting more traction, or definitely it's
there is a new attack called, I think, slope squatting. I don't know if Leon has seen this on the wild. That's that kind of slope squatting, but obviously it's a risk, a new risk.
Yeah, I agree. Just talking about these components, issues, and these things, we are seeing that last year we had like near 1 million of malicious packages from the last 2-3 years. We are now talking again about this attack on the NPM packages and this exfiltration and these kind of things. Probably they are not based on artificial intelligence, but we are seeing a huge increase of attacking the packages, doing this type of squatting, dependency confusion, not only generating malicious packages. I think this is the main issue today, the dependencies and the open source component in our software. So just to defend our ecosystem, what do you think, or in general, what are the patterns from these real world attacks to these components, or how we can evolve our defenses? And Luis, for example, I don't know if there is some specific indicator or something just to identify this type of malicious components. Just these 3 areas. I don't know if you can discuss them.
I think that the first victim in this war with AI coding and so on is the peer reviews, which is the best traditional mechanism to avoid the vulnerabilities, for example. This is the first victim, I think, with the new way of doing software based on a coding agent. So if you see that review time tends to 0, which is more or less the situation in many shops out there, you have to worry about that, because this is a risky trend.
This is the opposite of zero trust that Roman mentioned before.
Yeah, it's infinite trust. You see, you have the coding agent, and I use some of them. Cloud Code, for example, it's an agentic way of creating from some specification the code, and they show you the changes in code. And you get click and not even get a minute for reading that, because you have to work, you have to create the software, and you trust at the infinite point what the AI agent is doing, and you are wrong, because without review you are getting a lot of issues there.
I can add to that. I completely agree with you, and this blind code acceptance is really a nightmare. And again, we need to probably take the multifaceted approach here. But one of the emerging trends that I see is it's related to the concept governance as code, but in the nutshell, this is about those prompting MD files or agents MD files or whatever instructions or the context that we can give to the agents or to the LLM so that it understands how exactly it needs to generate code in our case, in the more secure way. And I see this notion or concept is evolving. Like a simple example, right, of it, like instead of saying, hey, write a login function, right? The better instruction would be create an implementation plan for login function, list all of the security constraints, edge cases, libraries you will use, and then let's test it, let's fuzz it after all, and etc. etc. So I see those evolving, at least as we use the kind of most popular AI assistant coding agents. That's the new way of the guardrails, I would say. That would be helpful.
I feel like everybody that uses AI is suffering from this problem. No matter if you work in development or if you're just, trying to like write your own reports for school. I think what happens is people see it, they use it, and then they see what it's capable of doing, and then immediately they trust it to just try to do the whole thing. And it does so much that people get inundated with it that they don't want to review it. And so I can't tell you how many, it's happening in every facet. Specifically in open source, for instance, they're getting inundated with a bunch of contributions, more so than you probably got in the past, but it's a lot of AI slop, right? People were like, oh, AI found this bug, here, submit it. And it's someone else's problem. I'll just try to cheat my way through it. And everybody's doing it. From a hacker standpoint, people were just throwing out exploits. It doesn't impact us as much because we don't care, but it's also happening on the developer side because you do something and you develop a little trust. You're like, okay, it does it enough times that you're just like, okay, it's good. And you get conditioned to this, which I think nobody wants to work, right? The more the reality is you have to make the process a lot longer. Where you could say just do it, and it would do it 100%. It wouldn't be right, and it'd be something wrong with it, and you'd probably spend a lot of time trying to develop it. And like Roman said, the best way to do it is like slowly implementation. Let's do here. Let's verify that. Let's do here. Let's verify that. But that means it's working. You're not utilizing AI as fast as you could. You're now just working. You're just 2 times as fast as you were versus 10 times as fast, and that's the problem, right? And then your boss is like, hey, how come it's taking you so long? Don't you have AI? You're like, yeah, but you still have to do this thing. It's not there yet.
Yeah.
Roman, just a moment before I mentioned the provenance. I am too old I remember the CVS comments in the files saying this was created by this guy, and probably there is no. I can tell the AI coding agent to put a comment saying I am Cloud Code and I wrote this code, this part of this function, but nobody does that. And so you have code that nobody knows where it came because the committer is a person, not the code. You don't know who created that monster.
And there's also like the incidents where people now, because it's new, people don't feel comfortable saying that the AI did it, so they want to take credit for it, but it's not. So they're not even being honest about it. So they're submitting code that you think is human created, and then there's telltale signs when you look at enough of it, but still, that whole is causing a lot of problems as well because you expect a certain level of, security, or I don't know, maybe not. It's people. Insecure inputs.
Yeah, that's true. To code points specifically, yes, I agree with you. And we try also to work among other industry players to understand how we can better provide the guidance for the developers to, who uses this AI code assistance, basically everybody, to include something like assisted by and etc. But when it comes to the real things, to the legal things and etc., there is no so far definition of of attribution code to machine or to AI model and etc. Ultimately, somebody should be responsible for it. And in in our development world, it's committer or maintainer ultimately, and etc. That's why I see some of the communities, they deliberately declining all of the AI contributions. I see it would be really, really hard actually to verify that there is no AI contribution, but they put the policy for their communities in place saying, hey, we don't accept any AI assistant code because of the legal risk, because of the security risk, because of the lower quality and AI slop, as you mentioned. I think we are advocating for the enablement approach from that perspective, to say, hey, yes, we kind of accept AI contributions because everybody uses AI nowadays, and we believe this is our future, this huge amplifier. But there are the the guardrails, whether ethical or or procedural, or the recommendations how to document well that this code is AI assisted and by which model or by which tool. It is not the solution for the problem, I think, or at least not the entire solution for the whole problem. But I think that would help to build the culture, and it would help then to verify these things. So this is for the code itself.
No, go ahead, Luis. At the end, what I am understanding is two things that you introduced before: trust and the provenance. Trust. Try to change that part and the provenance. But I don't know, for example, the provenance and both topics or both recommendations apply to the components and to the code generated by the people or by the system. So at the end, but probably I don't know what type of provenance of information. For example, Luis mentioned before the author or the publisher or the maintainer you have mentioned. So if someone have to check something before having the issue in the CV database or whatever, what are the things that they can use to validate and to check, or to try to validate that something is not an attack or something strange?
Yeah. So if we're slightly kind of going out of the code itself, the provenance. If our listeners who are not familiar with the concept of the provenance, classic provenance for the software or software artifacts, it comes from the SALSA standardization, which is under OpenSSF as well, happening right now. Basically, the idea is to attach some of the metadata or some of the additional artifacts to whatever builds or kind of piece of code you're producing, so that it's kind of passport, and it is additional information how this artifact was built, by which tools, by whom, and etc. etc. So this is the concept of a classic provenance for the builds for the software in general. Now, among with the other industry players, we're trying to think how we can expand this concept to AI worlds. For example, if you see again how we as an enterprise build these AI systems, we consume AI models probably right away from the open source, and we don't know how these models being trained. And that's why the concept of the data provenance standards comes to play. Basically, guides all of these models creator or models builder to put these additional artifacts to this model, saying, hey, this is origin of our data, this is geography, this is collection method, or consent if it should be given, or what the license of the data itself that's been used to train the model, so that later down the chain, down the cycle, we're not experiencing all of these legal problems, for example, or of this misunderstanding. And it's all, of course, machine readable, right? That's why we're talking about, okay, how to attach it and how to verify. Now it goes down to AI model card, which is kind of the understanding how the model itself been built, developed by whom, intended purpose of it, again, capabilities, and etc. And finally, we introduced just recently the concept of AI system card. This is the artifact that's attached to the AI system itself, because the users, right, all of us, we don't interact with AI model. Typically, we interact with an application, GPT or whatever, or the AI system, whether internally inside the companies or externally as the kind of private users. So that we come up with this idea: why don't we introduce the specification for AI system cards, which would serve as a nutrition label, right, for the entire application, documents the complete AI operational environment and platforms and system architectures and the models that I used under the hood, including security posture, changelog, and fixes and CVs and etc. So, and this spec is also machine readable, of course, besides being a human readable. So that we call like the provenance for everything, starting from the data itself, going down to the model, and ending up in the AI system. Quite new concept, but getting traction right now.
There is another component there, because you have MCP servers. This is the element of connection between the model and the tools that are later used for maybe calling, performing some commands, running some commands. Those should be also part of the provenance, because it's how the software was built in the end. So it's the surface is much higher than we expect.
That's always the first thing I look for is what can you do? Almost the first question, what tools do you have access to? And it's like, I have access to these tools. And so it's like, oh, those are the arms. Thank you. Okay. I know what my targets are now. So
very good, very good. Let's try to just I was taking note on this AI system cards and this proposal and the guardrails that you mentioned before. We don't have something that is machine ready. We cannot implement the guardrails in an automatic way. So yeah, I see that we have like a new set of tools that are appearing and should be adopted by the community and these kind of things. Very, very good. Well, we have mentioned, it's just a question, we have mentioned that the author, the publisher, but I don't know if there is a way to have the reputation of these people, because, okay, you can have the author and the people that has written something or has published something, but I don't know if we know this person or these people, or how is related with the trust. Is the first thing that this person published something, or in case of these repositories or registries with open source models and these kind of things, okay, we can have information about the intention who build things, and I don't know or how can we trust in them if it's related with these new capabilities that Roman has mentioned, or is it still something that is under development?
what's your question? How can we trust?
Yeah, is how
You
is you can, right? There is no problem. Okay. Very good. So we have mentioned ways to
simple answer. No trust. No trust.
No.
Yeah.
Okay.
No reputation.
It's clear.
You can use it, but just don't trust it. And so as you use it, make sure that you have guardrails and protections in place to say, hey, this is what's coming on. I look at this, I verified it's good. In this particular case, we're going to put it on a shelf. We're only going to access it this way. We're not going to. The problem here is as we're seeing multiple times, especially with these NPM packages that keep spiraling out of control, is that we have too much trust. There's too many dependencies, and that's trust. And so there's trust through all your applications. I mean, what that just came out? I don't know if we're going to talk about it at some point, probably. Supply chain attacks, and but we were preparing for this. There was one that we were going to talk about, and then another one came out that's worse. It's just this is part of the problem.
Yeah, just to quickly add to it, I completely agree. Trust no one, but and always verify at each stage that is possible. For all the things that I was just describing, of course, there is the way to sign them using like the brilliant open source project like SigStor and etc. So that later down the chain, developers or defenders in the organization, they can verify like these artifacts are signed and at least trusted somehow. Right, but I agree with you. It's like only the level of trust that we can give, but also I would advocate that there are tools already available, and there are tools that are under development that can supplement all of these concepts of give the descriptions, give the S bombs and AI bombs now, and then once properly signed and properly kind of crafted within the specs, they can be verified. And the some degree of trust could be established. Yeah.
Okay.
There is one project, one OpenSSF project, which is some sort of confidence scoring system for packages, for open source packages. And we saw it. We are using it for qualifying, which is the degree of trust I can have on a third-party dependency on a package and their versions, because it is evolving, and indirectly on the publisher of the packages. So we have that scoring system, but it's internal. It's not published. It's internal because it's appropriate for us, for our needs, but it's not public. There is no public reputation index out there. So.
No, I was asking more in this line if there is something generic standard, something like that, yes, for reputation, for trust, scoring, and this kind of thing, because it would be a good point probably. But we are a bit late, but I think that we are having an interesting discussion, so no problem. I have more. I would like that we have mentioned problems with the usage of the artificial intelligence components model, or for developing or for doing things, but Leon mentioned it at the beginning. Okay, we can, or attackers can now evaluate the landscape quicker, for example. Okay, so what's in the side of the defense? Can we use the artificial intelligence? For example, Roman mentioned that we have to analyze the SBOM, the meta information, and all the things. Can we use artificial intelligence to accelerate also the rhythm of the defense team to evaluate or to do this assessment and everything? I don't know. How do you see this part?
So I'm on the offensive side, right? But I think that it's absolutely imperative that it's used on the defensive side, because I don't think that you can keep up with the offensive side if you're not using it, which is sort of a double-edged sword, right? Because the systems that you're using to protect yourself sort of can be attacked. But I think that's just the nature of the beast. I think it's sort of a requirement, because how else do you filter out the noise? And I think what's happening is, historically speaking, we've been focused on like signature-based attacks and verifying things from signature. And there's been a slow push to behavioral, but I think now with AI, there's probably better ways to tune that behavioral identification. And I think that's probably where we're going to end up heading, because with polymorphic type of code, it's sort of getting impossible to just fingerprint things. And not only that, with AI, I can send custom payloads to every single person. So it sort of fingerprints your system, and it's unique to you and unique to you, and you both work at the same company, but it's like because of your behavior and your profile of what you're doing. And when you're talking about attacks like that, it gets a lot more hard to triage, I think, just knowing how would I find myself. And so you have to look at anomalies, but then you have to understand, how do you identify what's a baseline versus an anomaly? And I think AI can help you in that solution.
Yeah.
Yeah, I think AI, of course, is super helpful on the defense side, and a whole bunch of things spanning from the ops, SecOps things, right, and the SOC, and says to your point about how we're going to defend and figure out the attackers like patterns and what's happening. But also I think AI is helpful for the developer related and software related issues as well. And the classic things like you mentioned CVs or SBOMs. And I think a lot of companies that trying to play with AI and prototype things. We also do this, and typically what we do it in open source and make them open source right away. I could mention a few examples. We kind of developed the AI platform that designed to analyze, for example, Linux packages for vulnerabilities, which is quite kind of useful for Red Hat because we are a Linux vendor, right? We consume a lot of things, and this is extremely hard to your point previously stressed. It's extremely hard to triage all of these thousands of CVs in the dependencies in the packages, and we developed this AI platform to find the kind of missing hardenings, for example, weak cryptography implementation, or I don't know, we also combine this with static analysis, of course, trying even to reproduce some things across all of the platforms that we care of, whether it's RHEL or Fedora, and etc. etc. So this is kind of one example, and of course we use the plain English to kind of prompt this tool. Also, we use automated triage solution that designs to process security incidents for all of the vendors, for all the product vendors, and Red Hat, of course, is not an exception here. We have tremendous amounts of security reports that's coming down our way. And as we have been discussing already, there are a lot of there are significantly more garbage right now with all of these AI slops and etc. But even without that, we have a lot of security reports and incoming kind of incidents and etc. And of course, we use AI now to help us to distinguish between legitimate security concerns and spam, right? And once it's confirmed, for example, and fixed, we also use this tool to help us write CV description if needed, or whatever response we would need to create for this incident. Yes. And probably the last example, we have a lot of them, but I'm particularly proud of these that I mentioned. The last one, I promise this is the last one. Aegis AI. This is again actually open source tool. You can use it right away. It is AI agent actually developed by our project team that integrates with whatever LLM that you want, and even with the local ones, to automate and enhance security analysis on artifacts such as CVs. You can also feed this with SBOMs and additional information, and then it streamlines the workflows by providing capabilities like identifying PII, right, the personal information, explaining discrepancies, or what does it mean, the CVSS score. It could be connected to the different databases, can search for the kind of meaningful information about this particular vulnerability, and etc. etc. So this kind of Swiss knife for security teams, and this designs mainly for internal security teams. So that's why it works well also with a closed or rather open source models that then you can run locally. So that's how we use AI in the nutshell. Just a few examples.
Very interesting. Pretty much.
Okay. I can align with Leon on the maliciousness side. Okay, so we know on the vulnerability side, we know that AI is being used for assessing if something is vulnerable or something has a third-party vulnerability, which is the breaking changes that could make the version bump, the traditional version bump, unavailable for that particular vulnerability. That's on the vulnerability side. But on the maliciousness side, you need to look at how malicious packages are getting into your systems. And we see two kinds of following a phishing analogy. we see two kinds of packages there, malicious packages. One, we call them anchovies, which are quite trivial. They are not sophisticated. They use some obfuscation perhaps to hide the attack payload, but they are used. The most common thing they use is type squatting, trying to get some AI coding agent that mistypes the name of the package, which is not the. So you get some victims there, even with that trivial approach. But there is a second group, which we call the sharks, and the sharks are pretty much dangerous because they are stealthy. They have a lot of much more stealthy approach. They obfuscate the payload. Even they use steganography, which is something that is amazing. And for example, I will give two recent attacks that follow each of these parts. One is the 𝐐𝐤𝐿𝐷 worm. Maybe you have heard this case. It's the first NPM worm that propagates itself, trying to get the NPM tokens and publish in the victims managed packages. Integrates itself, which is like a traditional worm, and this is an anchovy because it's quite easy. It didn't bother to. It was quite noisy. For example, it get a private. If it has the GitHub credentials, it got the private repositories and published them, which is quite noisy. It's not stealthy, and it take a lot of headlines in the news because it was interesting. But there is a kind of copycat, which is the glassworm. Glassworm was a VS Code extension, a malicious one, that put new techniques that were known, but on the academy, academia, not in the real world. And my feeling is that this was something that was created, that was cooked with AI help, because those techniques were never used before. So we are looking at how we can detect that kind of sharks, which are the real problem, the real risk, because they affect many people if they gain access to popular components, and they can replicate themselves. It's a pretty frightening situation now.
Luis, very interesting, these anomalies in the field and the changes in the packages. Something else regarding, I don't know.
𝐐𝐤𝐿𝐷 was trivial.
𝐐𝐤𝐿𝐷, yeah.
Because you have a package. It has no post-install script, and in a new version, you have a big post-install script obfuscated. What's the reason to have a 2 megabytes post-install script highly obfuscated? There is no reason. It's obviously there is something that you have to hide there. So I think that anomaly is enough evidence to classify it as malware.
So obvious, again, it's a behavioral, right? We have to identify the behaviors, and the problem is how do you identify behaviors that you haven't thought of yet until they happen, and then you're like, oh, okay, I'll put that on the list. Don't do that.
Well, you have anomaly. You look at the regular situation for that package, and if you see changes, you have to check if the changes are evidence enough to classify the new version as malicious one. And then you try to analyze the payload, the attack payload, and try to check what it's doing, which is not easy because it's obfuscated, and it's not easy to deobfuscate in many cases.
So currently, I'm focused on privacy. Is what I'm sort of doing. I'm sort of like, as AI has exploded, it's become more apparent that the data is the goal. And previously, we talked about data, and it's always like people are hacking for data, but now it's big business, right? Everybody's putting paywalls over their data because they're training on it, and everyone's starting to understand the value of that data, and it's starting to get exploited in a much different way. And when you think about LLMs, ultimately, you have some sort of data that you're trying to give to your customers, and you're trying to do that as efficiently as possible for the users, but you're using this screen door to catch water, which is the AI. And so that's adding to the complexity of the problem, I think. So these things like 𝐸𝐤𝐻, these worms, I feel like as we progress, it's just going to get worse and worse, and until there's some sort of like, okay, we know now that the AI can't access the data directly. We have to put it in a repository, and it has to be a bunch of checks that are not AI related, and then the AI can access this clean data set or something. And I think there's going to be some sort of environmental solution, and I'm sure there's people are working on it all kinds of ways. There's all kinds of different guardrails that exist, and maybe you even know of some that exist, but they're not ubiquitous. Everybody's not like, okay, we all agree this is the right way to do it. It's sort of everybody's trying to come up with a solution, like you guys have your own internal solution for scanning packages. But I don't know if we'll ever get that there, because when you think about it, like how many people still have unpatched systems from, like that was the biggest problem in the day. And now they're telling you don't patch systems because if you auto patch. so what do you? So if you're a novice and you're not even in the space, forever we were yelling at you, patch. You have to be updated, patch. And now you're like, whoa, don't patch, don't patch. So it's
patch, but do not let the AI patch by you.
Yeah. You patch it. Don't let the AI patch it. But even still, like if you download the package, it's a legitimate package. I mean, some of these compromised packages were all like, we saw CrowdStrike in there. Like, what are you doing when your protecting tool is the one that's the door? So
yeah, exactly.
So thank you very much to everybody. Sorry, finish.
No. I was going to say, I can't tell you how many times I've compromised networks using their security product. Like the product is the reason they got them like compromised, because historically speaking, they were like, we have a security product. It has to have domain admin abilities to do what it needs to do on the network. And you're like, okay, well, if you're going to give me that, I'm going to attack that system now. And it's always an offensive thing, not a defensive thing. So it does things that are sort of risky in nature.
Yeah, I took note on this sentence of your security product is the door. So we have finished the time. I would like just to take some minutes from your side, just to finish. Two things from every one of you. One, how do you see the next steps in this context, in these things? Yes, the takeaways for the audience, just they can apply something in their day-to-day tomorrow, for example. So they have some clues or some tips or some recommendations for them from a practical point of view. So these two things from every one of you. I don't know the order as you prefer.
Probably I can start. Yeah, I think we live really in an interesting world, right now, and it's really hard to predict what's going to be next. But I think we're moving from we're changing roles now, or changing mindset, or what I recall. We're moving from the developers who know the syntax, who know code, to the next generation who probably don't care about the certain programming languages, but they should know the architecture. They should know the good patterns and bad patterns, of course, so that they can create the new code, the new products in secure manner using AI, obviously. So that's no doubt. AI is with us forever, maybe, starting now. So we just need to adapt to it and not building the walls, not denying all of these things in order not to have shadow AI and etc. So the kind of educational thing is the one part. On the other hand, we have been talking about this is the example of attack, but the type or the the category of the attack is not necessarily brand new. It's all about secure by design or secure by default, or making sure we don't trust, right, the zero trust and etc. So that's why I think secure by design just need to be applied to AI by default in defense, right? So that's gonna that's gonna get you success once you defend it. And tools and standards are all important. Look into them right now, but they're kind of complementary and would really allow you to do better the right things that you should already do. Yeah.
Thank you very much.
That's my take.
Leo, Luis.
Okay. Just one claim. I always claim that the root cause for the initial breach for many supply chain attacks is not always known for many of them, and this is a bit disappointing. When disclosed, attacks are typically technically dissected. You know what the attack payload is doing, but you know how the attack started. You know the root cause of the initial breach, and if you don't know how it started, how it get the malicious package, for example, was published in the npm or in the registry, in the package registry, you will commit the same mistake if you are a developer. So I think that we should also disclose with more care the initial breach, how it happened, because this is the one way of preventing many of the attacks that are causing the open source ecosystem. And one practical action, not pretending to sound like a self-help book, know yourself and your security stance. It's the same as risk assessment, if you prefer. What is the risk your organization is incurring when doing software in the modern way, with AI code assistance, with automating most of the build and delivery process, including security words? What are the risky points, and what are the words, the word rails that I am putting to counter those threats? I think this is know yourself is the primary action you should follow.
Thank you very much, Luis. Leon.
I would say lock down your dependencies. Everybody just lock down your dependencies and move slower. I mean, we're all going to use AI, and it's running out of control, and it's super fast. And but I would say just take a little bit of time to ask it more questions when you're doing things, because I think it's easy to get lulled into the oh, this is so good, I don't have to think now, or I don't have to, it can do it for me. But the reality is it has a confidence that you don't have, and it'll be wrong 100%. It'll 100% tell you something very confidently that's wrong, and you'll act on that information, and that'll be the downfall of you. And I think it's ubiquitous with anybody that uses AI. Like, there was a lawyer who submitted case law that didn't exist, and he got in trouble with it. And the same thing happening with like dependencies. And I don't even think the dependency, like the AI hallucinating dependencies, is the worst thing. I mean, it's a bad thing. But if you think about broad scale of these attacks, how many systems are going to compromise with that? You'll definitely get some systems, but that's the foothold. And that's, like you said, what's the foothold? And the problem, the problem, I think, with security as a whole, which is also why I work on the offensive side, is that all I have to do is find one way, and the defense has to like block all the ways.
Yeah.
And it's just not a realistic goal. And so that's usually why I'll stay on the offensive side, because it's so much easier.
Asymmetry.
Yeah, very much. I can find holes in all your problems. Look at that. What about this? What about that? What about this? And you have to just sit there with all your fingers and all the holes trying to stop all the things. And it's just, and I'm just like, look at that one, And so, yeah.
Thank you very much, Leon.
Good luck, everybody.
Thank you very much for all of you. So, well, we finish now. I hope the session was interesting for all of you. I think that the session today has shown that there is one message that stands out, is that the open source and artificial intelligence is now in the ecosystem and define both the speed of the innovation and the scale of the exposure we have. Okay, so what we saw in the session today is that how offensive artificial intelligence is reshaping the boundaries of the trust, how these supply chain attacks are growing faster than traditional defenses, how developers can introduce new risk through code without validation, selecting hallucinated components, and a lot of different ways. The good news is that we also saw that in the other side, the defenders can use the artificial intelligence also to enhance the SBOM analysis, autonomous triage, reduce noise, accelerate prioritization, accelerate the decisions, and keep the control over the software development life cycle. So I think the main things, the path forward is clear: visibility, trust verified, automation guided, and community connection. Okay, so all the teams can combine all these principles to create this resilience to our system. Thank you very much again, Roman, Leon, Luis, for your insights, your experience, your point of view, your tips in the final part. So that's all. Thank you very much to everybody for being here today with us and be part of the State Talk. See you in the next session. Thank you very much to everybody. Okay.
Thanks, bye.